So ladies and gentlemen at home, obviously example 2 did not get recorded, but we're going to example 3, and hopefully it'll make sense. Example 3 looks at the reciprocal function 1 over x. Right? And so as a sketch really quickly, what does that graph look like? The parent function right over here. It's that funny looking weird one. Something like that. Everyone agree? Everyone okay? And again, it's on your package. These, I call them the 6 critical points plus one more. That 0, 7, I'll explain that in a moment. Those are the 3 there, and these 3. The last one is here, because even though 0, 0 is not a point that lies on the function, 0, 0 is the intersection point of the vertical and horizontal asymptote. And again, if you kind of don't remember what that is, or you're kind of confused, don't panic, it'll make sense. This, however, for question example 3a, it says f at x minus 3. And what does that mean in English? I think everyone agrees. This is clearly a horizontal shift right 3 units. Let's just pause there. Everyone okay? Everyone agree? Understanding? I actually do this one before I even attempt the mapping technique. Everyone okay? So, what does that mean? Well, all our y values for this mapping technique is going to be negative 0.5, negative 1, negative 2, nothing there, 2, 1, 0.5. So I think a lot of you know what I'm going to do with the x. I'm going to do x plus 3. So what is going to be the new point? Negative 2 plus 3? Well, that's 1. Negative 1 plus 3? That's 2. And then negative 0.5 plus 3 is 2.5. 0 plus 3 is 3. And I know, again, this point seems weird, because if x was ever 3, it would be undefined, right? Keep on going. Adding 3 to that, it's 3.5. Adding 3 to that, that's 4. And adding 3, that's 5. Now, here is the trick, and again, I apologize, I don't have a grid. I wish I did. Even though these 6 critical points lie on the graph, I tend to use, for this function, this one here, because it helps me referencing, especially for translations. You'll see in a moment when we get to the stretches, this thing doesn't matter. This 0, 0 is the intersection of the vertical and horizontal asymptote. And just to show those in blue, I think we did blue. This will help us gauge what we do. And I'll do a new one for this one so it doesn't get so long. So it's a horizontal shift right 3 units. So if I take, even though 0, 0 is not a point that lies on, because it doesn't exist, this intersection point does. So moving at 3 units to the right, that's going to be 3. So already you can kind of tell where those transformations. This negative region is going to shift over here. This positive region is going to shift over here. So again, it's actually easier if you have some graph paper at home, ladies and gentlemen at home. This critical points are going to be these 3. That one's this one, there, and there. So you need someone look at this, and someone look at this. And that's what we're doing. The equation for this one would be, I think everyone agrees, for question A, hopefully you guys can see this, I think it would be y is equal to 1 over x minus 3. What is the domain? The domain would be, looking at the graph, it seems to be any real number except when x is equal to 3, right? Let me just double check that. And the range is going to be y belongs to real numbers, but y cannot equal to 0. There is a gap, right? So then we cross. So that's the domain range for that. Any questions about example 3a? we need me to make it a bit larger. Let's get someone in the class to help us out. What do you think this means? And again, don't get me wrong, notice, I know it's the reciprocal function, but I think we're combining the two translations. Maybe Sanaz or Alex? Wanna try? Anyone wanna try? Alex?
Horizontal shift left 2 units and vertical shift, vertical shift down 4 units.
Nicely done. Horizontal shift, left 2 units. Vertical shift down 4 units. And so just to show us what we're doing here, left unit to -2. This one's going to be -4. I think that's right. So let's just do this. -2 minus 2, that's -4. -1 minus 2 is -3. What is that? I can't do that. I don't do it this way. I actually don't. I don't do it. But anyways, -0.5 minus 2, what is that? -2.5? Is that right? Yeah. Thanks, guys. You're the best. 0 minus 2 is -2, which doesn't really count. 0.5, -1.5. 1 minus 2 is -1. -1. And then 2 minus 2 is 0. Yeah. And then for the y values, oh my god. -4.5, -5, -6. Now this one's interesting. I'm going to treat this as 0. So 0 minus 4 is -4. I'll highlight this like so. 2 minus 4 is -2. And then 1 minus 4 is what? -3. And 0.5 minus 4, that's -3.5. Hopefully I did that right. Now let's just move the screen over to the people at home. Sorry, Maria. There's too many shifts. Oh. And again, it's easier probably if you had a better grid. Oh, I went left. I gotta do this. Let's try that again. Hopefully it's easier on yours. So if you put the critical points, you should be okay. Let's redo it again. Make it a little smaller. 1, 2, 3. So what I like doing, again, ladies and gentlemen, although the parent function looks something like this. I just made it larger compared to what you see. Hopefully, you can see that at home. Yeah, looks pretty good. Again, 0, 0 is not a point that lies on this graph, right? But if I follow the translation that I think Alex told us, it goes left 2 units and then 4 units down. So 1, 2, 3, 4. So I think blue and orange. So going left was orange, and going down was blue. And the blue and the orange represent the asymptotes. So even though I don't use the critical point, that is a nice point to actually help us out. And then all these points are going to nicely follow suit. So a lot of you are going to already tell it, -1 and -3. That's this transformation. 1, 1. Transform to -1 and -3. A lot of you can see that I can do it, even though there's no grid, I can do it in my head. And same thing with this point, -1 and -1, which is this point. should be, if I could read this graph right, -3 and -5, and it should be -3 and -5. And then the other ones kind of follow through, right? This one definitely has no stretches or compressions, and again, it's easier on the grid. And there should be that should be 0. There. And I should have used a different color, but it's too late. And this one is the new transformation. What would the equation look like? It would look like this. Y is equal to 1 over x plus 2.
What would be the domain and range?
What would be the domain and range? Any volunteer want to try? So let's go with domain. What would be the domain? Brendan.
X equals real number. X is not equivalent to -2.
Nice. Because if you were to draw this, Bridget, right, go from left to right, you go, oh no, this vertical oscillator is preventing me. But I have to keep on going on my journey. Well, more negative. Then lift up your pen. Hey, I'm really, really hot. Whoa. So -2. Problem. What's the range? Different volunteer. And then y belongs to the numbers. Bridget, what's that?
Y can't equal -4.
Nice. And that's why the graph actually helps more than actually the equation. And technically, a lot of you understand this concept easier, the domain part, and that's what we focus usually, ladies and gentlemen. It's because it's the restriction for the equation. So, I know we didn't get to example 4, but I think you guys can manage that yourself at home. And hopefully tomorrow we'll take up some of these questions from the exercises. The answers are there. And finally, before I close up for today, I just want to mention 2 great websites. Many of you know about Desmos.
Yeah.
Some of you may know about GeoGebra.
Yeah.
And you can definitely cheat by doing that. That's why you can't have them, obviously, in doing that. Thanks for watching at home. Hopefully that was okay.